Hey Paul, Inventor 3. So I decided to make this video to show you my project and kind of how it works. So here we have my switches for main power ran to the house, and here is the project itself. Now the coil is not supposed to be a Tesla coil or an electromagnetic coil like yours, but instead it's supposed to be kind of like a receiving coil, just to see for electron flow. So this is how all this works here. So right here we got to hit our breakers on. It looks like they're both on. Now I use this to test whether it's on. So that switch is on, and okay, so there's power to it. Now I have to take the fan off of that front end so it won't be so loud, but in the meantime it's gonna stay on. So this switch right here, this will be switch 1, 2, and 3. So we'll start with 1. Switch number 1 controls this electromagnet here and that one over there. Now switch number 2 is the main power for everything. So you can see I have my cord ran up onto it. It runs power all the way over to the breaker, all the way back to the switches, and all the way back to the project again. So that's switch 2, and then switch 3 controls these two these two transformers back there. So yeah, that's how they're set up. And as you can see, the black and white wiring right here, that's wired to this front transformer, and this second transformer is wired to this transformer. So now let me show you, because I don't have a voltmeter at the moment, I can show you what I do use to measure. I use this. This is my EMF meter, and there it is there. So we turn it on. I prefer to use micro Teslas as my form of measurement, so that way I can test the electromagnetic radiation coming out of it. As we can see, nothing here. Now the sound should be on, so I'm gonna fire this one and that one up by hitting switch 1. So we turn main power back on, and we hit switch 1, and you know, we can hear it's going off. So we could see 3 point, yeah, and then when you move it close to the electromagnet, you get the overload, and it'll slowly go back down. Now we'll turn off switch 1 and turn on switch 3. See what that does. This is what you get. From this distance you get that, and then eventually you will start to, if you get close enough, you will get your overload. Okay, so now I like to test around the outside too, so we can already see from right here it's kind of high. Right about here, yeah, standard. So I always stay a pretty good distance away when it's running. Like, I don't normally put my hand there to test it. Normally I set it that there, because I don't want to have to deal with electromagnetic radiation, you know. And okay, so we'll just test with 3 and 1 on now. Here we go. So I don't know if you can hear the electromagnets themselves humming, but they do hum a little bit. Now what I've noticed, sometimes I turn this upside down on the coil and I'll hold it there. Normally I can just leave it alone if I just kind of jam the tip in there. But we can see we get that fluctuation. Now, let me turn all that off. Now sometimes this styrofoam, I use volts per meter. So sometimes, let me hit these off. The styrofoam will hold a charge, And when I had my multimeter before I blew it up, I was actually able to get a pretty decent reading out of it, on a smaller scale. The styrofoam is so old though. It's been out here weathered so much, I don't even think that there's any real electron flow through it anymore. But for a while, this styrofoam, you can see it just peels right off. I mean, it's bad. But it was holding a charge for a while, and my issue became that when I was using my voltmeter, I was using it for stuff like this. Well, one day I left it unattended and not clamped down, but I left it attached to one of these transformers, and the transformer blew the fuse on it. Well, when I took it apart to replace the fuse, turns out I don't have the right fuse for it, so all that's on hold right now until I can get the proper fuse for it. I've tried to solder a new one on, and it has not gone well. I blew the second fuse as well, so I'm gonna have to buy the right fuse for it. But yeah, so this is my project. Now I will explain, this back here is nothing. These solar panels just power this dynamo, and this dynamo is connected to, you can see this wiring right here, dangling like that. That's for the dynamo, goes up in there. Now actually the dynamo right now is just wired to the coil. Now I didn't expect to get anything, but I made this a long time ago when I was trying to kind of achieve something you're working on now. So I was unsuccessful, clearly, but I also never continued that part of it. I decided to continue the work into electromagnetic radiation overall and creating a dense field of it. But yeah, that's the project. Well, let's look at the setup. So there it is. I'd like to hear what you think when you get the chance to, if you get the chance to watch this or not. But yeah, this video is for you, Paul Inventor 3. I hope you like it.